Hello everybody, Mr. Fritz here. We are going to talk about the greatest common factor and using greatest common factor in factoring polynomials. So that's where we're headed, and the GCF should be a review or a familiar term, but we're just going to refresh your memory and make sure that we all are on the same page with this stuff. So we're going to start off pretty basic, taking GCFs of numbers, and then we'll move on from there. As a reminder, here's kind of a definition for the greatest common factor, or the GCF. And it is simply just the greatest common factor that divides into two integers. Note that the big thing here is that it's the greatest common factor. So it's not any common factor, but it's the greatest. So it's got to be the biggest number that can divide into two integers. So there's a couple different methods you can use to find GCF. The one that we'll look at first will be the prime factors method. And basically all we're doing is we're going to take two numbers and we're going to figure out what the prime factors are and see what they have in common. So let's break up 25 into, well, really the only two factors it has other than one in itself. We have 5 and 5. So we're done. We can't break that down any further. Those both are prime. And then let's take a look at 10. We can divide 10 by 2, and what's left is 5. And those are both prime numbers also. So now what we're looking for are the common factors between these two breakdowns. So I see a 5 and a 5, and since I have 1 5 in common, that's going to be my prime factor. And it looks like that's it. I've got no other common factors, and so this will be my greatest common factor. That's a pretty straightforward one. Let's take a look at one that's a little bit more complex. And you know what I'll let you do is, if you feel confident and you want to try this one out on your own, I'll put a little link to skip ahead, and you can zoom ahead so this will be completed. And if you're staying with me, let's take a look at the way that this breaks down. Okay, so 36, when we break this into 2, let's see, I like to divide it by 2, and then what we have left is 18. I'll break 18 into 2 and 9. I'll break 9 into 3 and 3. And then 27, let's break down into 3 and 9. And 9 will break down into 3 and 3. Okay, so now I'm looking for my common factors. So I've got a 3 here, and a 3 here, and a 3 here, and a 3 here. So it looks like I've got 1, 2 pairs of 3s. So my greatest common factor is going to be 9. So the GCF of 36 and 27 is 9. Okay, so if you skipped ahead, here's the answer, and you can check, you can skip behind or scroll behind, rewind, that's the word I'm looking for. Rewind if you wanted to see how I did it. Otherwise, let's keep moving forward. Okay, for these next two here, we're not going to actually make a prime factorization tree, but we're just going to list out the prime factors. I think that we can handle that. So let's take a look at this first one. If I want to write out, I want to find the GCF between 2x cubed and 10x. What I'm going to do is let's write out all the factors of 2x cubed first. So I've got 2, and I've got an x, and then I have an x, and then I got one more x since I have x cubed. That's my 2x cubed, and for my 10x, I've got 2 times 5 times x, and actually, oh, that's it, just one x. Oops, too much. Okay, so when I look at my listed factors, it looks like in common I have the 2, and I have a pair of x's. So that means that my GCF is going to be 2x. That is common between both of these, and it's the greatest common factor between both the 2x cubed and the 10x. So shifting over to number 4, why don't you give that one a shot on your own, and I'm actually going to skip ahead here. Okay, the answer for this one, number 4, is x squared y. And so if you want to see how I did that, you can take a look at the work I have up here. We're going to move on down though. So now we're going to use the GCF, the same concept of finding the greatest common factor. We're going to think of it as reverse distributing. When we're taking a greatest common factor out of polynomials, we're going to see those 2 terms or 3 terms or 4 terms right in one polynomial. And from that polynomial, we need to extract the GCF from each one of those terms. So to start off with, what I would do is I want you to take a look at number 1 and number 2 and see if you can, on your own, figure out how to make this an equal statement. The 3x plus 3 is going to equal something times the quantity x plus 1. So see if you can figure out what you are factoring out, taking that greatest common factor out of this left-hand binomial. And then see if you can do the same thing with number 2 here. So why don't you give that a shot, and I'll come back in a second. All right, so I completed number 1 for you. The answer here is 3, and you can think about it if I were to go in the other direction and distribute. I would get a 3 times x, and the 3 times 1 would give me the 3x plus 3. If you're having some trouble with number 2, take a look at this. I'll explain it out for you here. Otherwise, you can skip ahead, and I'll put an annotation somewhere in here to skip. So what we're after here then is to figure out what term can I take out of, or factor should I say, can I take out of a 5x squared and a 10x, that when I multiply it by x and 2, it's going to be equal to this thing over here. So I'm trying to figure out how to extract a common factor between both of these terms. And so an easy way to think about this is if I have an x plus a 2 left, what did I take out of 5x squared to be left with an x? Or you could also think, what did I take out of a 10x to be left with a 2? When you are reverse distributing, you are using the reverse operation that we used when we distribute. When we distribute a number, we're going to multiply across, and if we reverse distribute, we're going to be dividing. So we're basically trying to ask ourselves, what is 5x squared divided by x? And what is 10x divided by 2? The answer to both of these will be whatever the GCF is that we took out, because these are the terms that are remaining from our reverse distribution. So the answer here, if you didn't get it already, is going to be a 5x. If I can double check it also by going the other direction. 5x times x and a 5x times 2 is going to come out to be 5x squared plus 10x. Now 3, 4, 5, and 6, these are a little bit trickier because you are going to be, you're not given kind of the end result, but you have to identify what that GCF is and pull it out on your own. So if you want to give any one of these a shot, you can skip ahead, and I think what I'll do is I'll throw an annotation after I work out each problem if you want to just skip to the end of the problem, and see if you got the right answer. So if you want to stay with me though, let's work on this together. So for this one here, my greatest common factor, I'm looking at these two terms and I'm thinking, what's, maybe I'll start with the coefficients. So out of 12 and 6, what's my greatest common factor? Well, it's going to be a 6. Then when I look at my variables, I have an x squared and I have an x. So what's the most number of x's I can take out of both of those things? Well, I can take out 1x from x squared and just 1x from x. And what do I have left? Well, I'm going to be kind of in my head dividing 12x squared by 6x. So that's going to, what am I left with? A 2x. And then I'm going to divide negative 6x by 6x to see what I have left here. And that's going to be a minus 1. And so you can start to see if I redistribute this 6x, I'm going to come back out with this 12x squared minus 6x. So it's all about trying to figure out the greatest common factor between these two things. Okay, let's take a look at number 4 now. Again, I'm trying to find the greatest common factor between these three terms. So again, let's start with the coefficients. I've got 15, a negative 6, and a 2. Well, I've got 1 prime coefficient here, so really I have to look to see if 2 divides into all 3 of these. And it doesn't. So I'm not going to be able to take out an integer coefficient for my greatest common factor. All right, so now let's look at the x's. I've got an x squared here, I've got an x here, and it looks like I don't have any x's in this term. So I can cross that off the list of possible common factors. There's no x in this last term, so I can't take that out. Then now let's take a look at our y's. So I have a y here, I have a y here, and would you look at that? I have a y here, and there's just 1. So I can take 1 y out of all 3 of these terms. And I'm reverse distributing here. So let's see what the pieces that I left when I extract a y out of every single one of these terms. So I have a 15x squared and I remember I took out the y, so that's gone, a minus 6x, and a plus 2. And again, you can always check by redistributing those terms. All right, let's see, number 5 here. Let's do this one together. I'm going to go a little bit faster now. So I've got a 27, a negative 63, and a 12. The greatest common factor. So it could take a little bit longer now that I've got all these bigger numbers here. And so I'm thinking to myself, okay, well, a 9 goes into 27 and 63, but it looks like a 9 doesn't go into 12. So I'm going to have to say that 3 is going to be my greatest common factor out of my integers. Next, let's take a look at the x's. I've got an x to the 4th. I've got an x squared, but no x's here. So cross that off the list. I've got a y squared, and a y cubed. So I think that 3y is going to be my greatest common factor. And what do I have left? A 9x to the 4th minus whatever this is, 21 x squared y plus 4y squared. And that's all I have left of this one. Now the last one, let's see, let's work on this one together. Look at my coefficients, 11, negative 6, and 22. I'm not seeing a greatest common factor there, so let's take a look at the x's. I've got an x squared, an x, and nothing over here. And then I've got for the y's, I've got a y, and nothing there. And looks like I've got a z squared, and nothing there. You know, I'm not seeing any sort of common factor. I can't really take out a 1 because that wouldn't change anything. So in this case, I don't have a greatest common factor, so I can't factor anything out here. So I'm left with the original polynomial. So that's how the GCF stuff works. You're going to get a lot of practice with this in that Arlington Algebra homework worksheet that I assigned. And I put a link for that below. So if you don't have it or looking for it, you can always grab it online there. But take your time with this stuff. Remember, you're thinking that you're kind of reverse distributing when you're taking a greatest common factor out of these polynomials. And just make sure that the terms left over are the pieces after you've divided out your greatest common factor. So work on it and hope it all goes well. And I'll see you in the next class.